Okay, hello everybody. So thank you to be here with us today. Today we're going to talk about IBM Cloud and Watson services on IBM Cloud. Watson services are actually AI services on IBM. So it will be divided in two parts. I will start with IBM Cloud introduction and catalog introduction. And Emmanuel will follow with more specific data scientist tooling parts on IBM Cloud. So just a quick presentation first. So I'm Clémence, I'm a developer advocate in Europe for IBM. What we do in our team mainly is developer advocating in developer events such as conference, workshops, meetups. We do hackathons as well, and all around IBM Cloud technology, AI technology, and data science technology. So I've been working for IBM in this team for almost 4 years now, and I'm really happy to be here. So Emmanuel, maybe you want to introduce yourself?
Good afternoon. So my name is Emmanuel. I'm an IT architect and a data scientist and a cloud developer advocate within the same team. I've got 20 years experience, a bit older than Clémence, in various pre-sales technical roles within IBM, always related to the data. And I've been also an industry solution architect working for government industry and retail industry.
Okay, so I will start with the agenda. So we'll start with really cloud basics and cloud introduction, and also about the IBM technology on that. Then we will see more about Watson services, so AI technology on IBM. We'll have a demo on the visual recognition service, which is one of the actually Watson service available on the IBM Cloud Catalog. And then Emmanuel will talk about Watson Studio, which is a tool for data scientists on cloud, with many options, many different tooling to process machine learning and deep learning algorithms. I will give a demo, and at the end we will have a toolkit overview for developers, and not only developers but for curious people about the technology. The AI and the cloud technology. So I don't know if you're really familiar with cloud. Can you raise your hand if you ever touch a cloud platform? Okay, so some of you are, but I will start with the basics to get everybody at the same level. So when we talk about cloud, usually we talk about IaaS, PaaS, and SaaS. So IaaS is the infrastructure as a service, PaaS is the platform as a service, and SaaS is the software as a service. The difference between these different cloud model, is actually the part that are managed by the developer and the part that are managed by a cloud provider. For example, IBM, for example, Google, for example, Amazon, for example, other cloud providers. So IaaS is the cloud model which leaves the developer the most customability on his application. It means that the developer will have to handle OS, middleware, runtime, and of course data and code. And what will do the cloud provider is to manage and provision virtualization, server, storage, and networking. So it's like you need some skills in your development team to do this part, OS, middleware, runtime management, to manage the different versions, to install whatever you want to install as an OS, for example. And you will have people dedicated to that. It's a lot of work. Well, it's still less work than if you were just doing on-premise without any cloud management, but it's still some different skills than just web developers and data scientists. So it's more customizable. About the money you need to invest a little bit more, but it's still it's still a cloud model compared to the on-premise classic model, where when we say on-premise, is that you have your own data center and you do everything. You have your own machine, and you have to buy all the material, install everything from the networking, from the bottom layer that you see here. On the PaaS model is a bit different because you have access actually to all the blue layers are available for you, and you don't have to worry about that. As a developer or as a user, you just need to focus on your code and your data. What it means is that you will have access to a platform through a URL, for example, but you can do also with command line, but you have a UI access to create directly your application on the cloud. And you don't manage any of the runtime, middleware, OS virtualization, and all of these layers that you need actually to run an application. When you have a web application, you need all these layers to make it work. But if you're using PaaS, you will just bring your application code and your data and create and develop your app, but you will not manage any of the infrastructure layers. So it's good because that way you can, in your team, you just need skilled developers, but you don't need to have any of the skills, such as infrastructure skills, because you just use it on the platform. Also, you can focus on your business. You can focus really on the code and on how to improve and to have the best algorithm for such a business that you want to do. And you don't have to worry about the material stuff. So for example, if you're a startup and you want to create your business, usually startups now, they are born on the cloud, and they create their application directly on the cloud, and they don't want to worry about all these infrastructure layers, and they focus on the innovation. And the PaaS model, the cloud PaaS model, is a way to go faster on the market, because that's why you win some time, of course, to get your application working. You can have it deployed. I mean, your first application can be deployed in I don't know, in half an hour if you want, and then it's online and it's ready. So thank you. So to create a business, it's a model which is really common now. Also, well, I will talk that about the next slide. You have different cloud deployment model. So here what you're gonna see on the demo is the public cloud model, the one that everyone can access with just the console, just on the web. But just for you to know that it exists within IBM different deployment model, because companies, depending on their business, on their data privacy problems that they can have, security problem, or just personal data that you don't want to host on a database on cloud. Usually they need different cloud deployment model. So actually you can use many of them and connect it together, or you can use just one of them. So the public cloud is the one that you create publicly, and when you create your application, it's you don't know where your application is running. You don't know. Well, you choose the region, but you don't manage any of the thing, and you can have your application running on the same server than other application, and it's not managed by you at all. It's public cloud. On the dedicated cloud, it's still on the IBM data center, hosted on IBM data center, but you have a dedicated environment for your organization. So that means that you don't share the materials with other users. And you still benefit of the same cloud public benefits. The same agility, the same way to work. And then you have the private cloud. So in IBM it's called ICP, IBM Cloud Private. It's when you don't want to use IBM data center at all. You want to have everything in your data centers, but you still want to use cloud. And then IBM can install for you an IBM Cloud Private just for you. And usually is what companies like bank need to run on the cloud. You don't have exactly the same offers on public, dedicated, and private. I mean, it's, for example, we'll see later the catalog of services which is available on the IBM Cloud. On the IBM Public, it's really large. On ICP, it's evolving. It's more, let's say, new. So it's evolving, and not everything is available now. So you have to look for what you need exactly on IBM Cloud to fit your business. So it gives you a seamless experience. You can create part of your apps in the public and on the private cloud. It's possible. You can use private cloud for your data, for example, and still use public services. It's something possible. You need to connect your different the different parts of your apps, and you can also use on-premise capabilities, of course, if you need to. So all of that gives you these five things. Cognitive solutions, because you will see that you have cognitive services available to you on IBM Cloud. DevOps productivity. DevOps is a methodology for developers, and we have several tools on IBM Cloud for that. Analytics, data. We have many databases on cloud, many services for analytics. Hybrid integration. So if you combine public on-premise over cloud as well, you can use IBM Cloud and also Amazon and also Google. You can combine different clouds. IBM Cloud is all based on open standard, just for that, to facilitate the integration and the hybrid integration. About the region, so on the map you see the different IBM Cloud data center. So you have about 60 IBM Cloud data center. And on the right, you see which are the ones available for IBM Public Cloud. So if you access public cloud from your laptop today, you will have the choice to create your application in these different regions: US, UK, Germany, Sydney. It's something that evolves as well. I think just this year we launched Germany and US East region this year, so it can evolve, and we can have more region for public cloud. Also, so on IBM Cloud, you have several compute options. So as we were talking earlier on IaaS and PaaS, on IBM Cloud you have actually both. You can use it as an infrastructure as a service, but also for its platform as a service components. You can create bare metal, you can create virtual server, which is more on the infrastructure side, but you will have to manage, of course, a lot more than on the PaaS. And you can create container, Cloud Foundry apps, and Cloud Function, which are more on the platform as a service part. When you say, for example, Cloud Foundry apps, it means that we have several runtimes available on IBM. So runtimes, it's like a language for your application, a programming language. So we have, for example, Python, Java, Node.js, Go, I forget, PHP. Almost every language are available as a Cloud Foundry, and you can create your apps using these runtimes. Also, if your language is not available, you can bring your own build pack to the platform. It's not a problem. You will just have more to manage the versioning of your runtimes compared to if you create now a Node.js application on IBM Cloud. You will not have no clue about. Well, you can know, but you will not manage, for example, the version of Node.js, these kind of things. It's managed by the platform. Containers, it's a really hot topic now, and it's available on IBM Cloud. We support Kubernetes, and for developers which want to be more flexible than using with a Cloud Foundry, you usually will go to containers, either if Docker containers. You have several images available that you can create, and you can port your own, of course, on the platform. Cloud Function. So I don't know if you work with serverless. Serverless, yes.
Like Lambda, Amazon Lambda.
Yeah, exactly. Yeah, exactly. So the IBM Cloud Function is based on OpenWhisk. So again, based on open standard. Yeah, it's if you want to write serverless application, it's possible. Just quickly, the architecture of IBM Cloud. So you start with choosing deployment options. So public, dedicated, private. Then you choose your compute option. So it can be Cloud Foundry, containers, or more IaaS if you want to use virtual servers, or Cloud Function and serverless. And since you have created or you have bring your code as choosing one of the compute options to the platform, you can add one or many services. Services, what we call services, is actually APIs available on IBM Cloud. So in the different area, we have data APIs. For example, we have data database on cloud. We have many databases like NoSQL, SQL. You can have a look if your favorite one is available on the platform. We have mobile services as well available to help you to create your mobile application. We have cognitive with Watson services. So we'll have focus just the next slide on that. Analytics, IoT, security. We also have blockchain. What again? And if you want to bring your own service or your own API to the platform, it's also possible. And then you just bring your code of your application, integrate the services with that, and that's it. On the left side, you see that you have different DevOps and what we call developers options. You can use the DevOps tooling to manage the life cycle of your application, do task tracking, task issues, but also versioning. You have a Git integrated with that. When you create your application, you can associate a Git repository, or you can associate as well your own GitHub repository. Yeah, I forget. So on the right, it's just to say that you can integrate with other environments, either external APIs, other clouds, or your on-premise system. So just about the developer tools. So what we want in IBM Cloud is that you can really use the tooling as a developer, the tooling that you like. So you have several choices to deploy your code. You can either code locally on your machine using your favorite IDE, and then use the command line interface IBM Cloud to push your code to the platform. I don't know if some of you are coming. We have a workshop on Saturday, and we will actually use this tooling. Or you can use also, if you're a Java developer, for example, we have a plugin in Eclipse which allow you to deploy your application directly to IBM Cloud, to the environment that you configure. It's easier if you're used to use this IDE to use the plugin than maybe the command line. And also we have the DevOps, the IBM Cloud DevOps toolchain. I don't know if you, yeah, here. So with different tooling, the delivery pipeline, the Eclipse Orion IDE. So it's actually a web version of an IDE. So you can actually don't do anything locally. You can do everything on the cloud if you have your editors. So if you use the Eclipse Orion IDE, you can edit your code directly on the platform, and then it's associated with a Git repository. You do your commit and your push, and with the delivery pipeline, it automates the build and deploy steps. So you commit, you push, and automatically it deploys to your environment, depending on the configuration, of course, that you set at the beginning. So on the CLI, of course, you can do it for Cloud Foundry apps, but also for containers, functions. So this is an overview of the catalog. So you can see that you have the compute services. Here, if you look at the menu on the left, you have compute, containers, networking, storage, AI, analytics, databases. For example, if you're using a NoSQL, you may want to use a Cloud database, which is an NoSQL DB. This is one we will use, by the way, on Saturday. Developer tools, such as the DevOps toolchain that we just seen before. IoT, we also have in IBM an IoT platform. So you have a service on IBM Cloud Platform called IoT Platform, and actually links your, when you create the service, it instantiates an organization on the IoT Watson IoT platform, and then you can connect for example, your web application or your mobile application to this IoT platform organization, where you will where you will connect your different device. If you have sensors that you want to connect, you connect it to the IoT platform, and then with the different APIs and connection, you can get the data and do your treatment in your application or whatever system that you are using. We also have some starter kits on the catalog here. So starter kits, it's actually examples of application, so of Cloud Foundry application. So it's usually one runtime and one or two service, and it adds just as it's an example. It's a template. You create it and you see how it's connected the service, how to call the different services, how to interact with your services to do something. So usually when you want to start, it's a good start with that. If you want if you are curious about some services, Watson services, for example, you can see one of the starter kits which enable Watson services. Watson APIs for developers and tools. So this is all of that. So on different categories: speech, language, empathy, AI assistant, vision, knowledge, and data. So on the speech, you have the text-to-speech and speech-to-text services available either to synthesize text or to get written the text that you speech. It can be interesting for interaction. If for example, if you're working on a robotic project, You can use these two services. For example, I have an example with a Raspberry Pi where you connect these two services with a microphone and speakers, and then you can interact with your robot. Also combining the Watson Assistant, which is the service to create chatbots. The three of them combining, you can create actually an assistant, a robot assistant. This is one example of implementation of these services. In language, we also have a language translator, NLC capabilities, tone analyzer, personality insight. Is to analyze the emotion. So tone analyzer will analyze the text depending of emotion on like the I forgot I will show you in the example in the demo exactly. And personality insight, it's more complex than that. It's you need like to give a big amount of text, for example, a resume or a biography, and it will extract from the text the personality of the person which is described in the text. So all of these services, they have a demo available on the web. So if you just look for it on your browser, if you search for it, you will see a demo for each of them, and you can usually with the demo you can test it. So you bring your text or your images if you want to use visual recognition of different services. Emmanuel will talk about the data part. So Watson Studio, Watson Machine Learning, and Watson Knowledge Catalog. So I will leave that to him. So yeah, I'm gonna give you just an example. I think I have 5 minutes for the demo. No? Visual recognition is a service that you can use in different cases. So it's to recognize tags in an image. So overlays, you can use the pre-trained model which come with the service, so which are given by IBM. In the pre-trained model, you have the general model, the face model. So general model, it will tag the picture with really generic things. So for example, there's a chair, a table, there's a gray color, this kind of thing. But you don't have the hand on that. You will just use it like that. Face model, it's on a face picture. You can use these capabilities to recognize the average age of a person, and if it's and the gender of the person as well. The explicit model and food model, they are in beta, but you still can test it. So on the food model is to recognize food and meals, and explicit models to analyze if an image is inappropriate or not. It will tag the image differently. The text model is in private beta, but it's also available on the demo. So you can test it on the demo, and if you want to use it if you have a real business case about that, you can register and apply to get access to the private beta. And if IBM say that it's a good business case and they want to give you access, they will give you access. Well, for the moment it's like that. Same, the services that are in beta, they can come available soon. And then, I forgot, you have the custom models. So the custom models is when you create your own model using Watson Studio, what Emmanuel will present. You create your custom model and the things that you want to recognize in your picture. So you train your model on your own pictures. So you need usually for one class you need at least 10 pictures, and you can then apply this model with the service to your. You can use it in your application to recognize what you want to recognize. So you also have the APIs available for the visual recognition. So you can use the tooling, the Watson Studio tooling to do it, but you can also do it with the APIs to classify and train your model and to get the different model ID and this kind of thing. But I mean, it's a swag, so you're a swagger, so you have access to it. So, quickly show you. So this is IBM Cloud. Huh? This is where the catalog is, and every time you click on it, so it's accessible by everyone. If you want to create one of the service or one of the apps, you need to register to the platform, and you will have a free access. It's a limited access, of course, in terms of data, memory, and number of services that you can create, but it's still free, so you can use it, and there's no time limitation, so you can use it to try and to see the different capabilities of it. Visual recognition. So for all the service, the Watson service, I'm going to go back to this first. Okay, so here on the Watson sales image, and I'm going to go to developers. So you can see here that you have access to the doc, and directly for each service, you can also access to the specific API reference, documentation. So let's see. And here you have general information about the service, how it works. Also you have small tutorials to know how to classify an image, how to use it. And usually you always have a demo link here. Here we are. The demo is here. So it comes with several images here. So for example, on this one, here you can see the results of the pre-trained model that are given by IBM with the service. So on the general model, on the face model, you see that there is no result because the image is cropped. There is no faces in the image. Food model, well, apparently there is no food, and explicit model as well, not explicit. And you see that it's actually describing the pictures, the colors, the see that it's recognizing the picture. So we can try with different one. So this is a chip. This one is interesting because there's some text on it. So you can see that it recognizes the text on the image here. So if you go to close the general model, and if I go on text, I recognize the different words on the image. And also, if you have a specific business case and you say, oh, maybe I could use this kind of visual recognition service, you can use it with your image to see what the pre-trained model gives as a result. And if it's something that works for you, it's okay. You don't even need to train your own model. But usually, if you really want to recognize specific things depending on your business, you need to train your pictures. For example, I don't know, we have a workshop on that, and what we do is to recognize good pizzas and bad pizza, bad condition pizza. Like this one is too burn, this one is okay. And for that, we create a custom model to recognize the pizza with many pictures of pizzas, and we tag it okay or not okay. And then with a new picture, since the model is trained, with a new picture of pizza, it's able to say it's a good picture, it's a good pizza, or it's not a good pizza. Right, it's just for the record. And well, you can use it with your camera as well, or bring an image here. And it does the classification. You can pass a URL as well if you have a, I don't know if it's uploading or not. Well, I'm gonna do it offline and show you the result when I have uploaded the picture. Right? Yeah.
So now I'm going to talk about a tool which is called IBM Watson Studio. And Clémence talked about artificial intelligence and a bunch of services. You just saw the visual recognition service, which may seem as a black box to you guys right now. Well, all the AI services that we have within IBM are pre-trained, they've got generic models, and they are in fact kind of black box. But there is also a tooling which allows to customize those and deploy your own artificial intelligent asset, whether it is visual recognition, whether it is textual understanding, try to extract concepts from a specific text, and these kind of things. So you're not locked into some sort of predefined service that you want to use. And this kind of paradigm is always true with all the services. And it needs tooling to do this, and that's what I'm gonna present right now, the IBM Watson Studio. So quite rapidly, because we're kind of behind schedule, what machine learning is all about, basically it's all about the traditional selection of algorithm, getting the right algorithm to do a specific prediction, for instance, to recognize a specific pattern, whatever it is. And that's tweaking a bunch of parameters. So that's machine learning, being able to select the right algorithm for a specific business challenge. Then deep learning is kind of ahead in terms of complexity, because we're gonna put in play dozens, and we're gonna tweak dozens of parameters in our neural network models to try to, for instance, recognize images, for instance. And where AI comes in is when we merge these things together. AI is a kind of bundle or an aggregation of all the things we can do in terms of machine learning, in terms of deep learning, and putting them together within what we call a system architecture or within a product. Okay, so that's put simply. We talk a lot about AI. There's a lot of buzz. A lot of companies claim to be AI-driven. They've been data-driven. Now they claim to be AI-driven. But still, in reality, it's kind of a big challenge for an enterprise. And the reasons for this is mostly related to these four challenges. Data. Data is there's data everywhere, pretty easy to get our hands on the data, but still it's kind of complex to analyze it because it's never in the it's never formatted the way we want it to be prepared, or to be prepared for analysis and so on. So we need to be able to manage this kind of a complexity in terms of data. Also, the data is becoming very heterogeneous. Comes in different forms, comes in streams, in real time, for instance, and that's a big challenge. Another challenge might be the governance. The data isn't necessarily secured. It might sit in silos which you may not have access to, and also we want to have a good understanding of where the data comes from, and that's particularly important when you're starting to ingest data from external sources. You want to build veracity, and you want to have a trust on your data, because if you're using this data to do decision well, to make up a decision, you need to understand where the data comes from, so that you really guarantee that you're taking the right decision at some point. Another key aspect is skills. When we talk about AI, we often reference to a job which is called a data scientist, which is kind of seen as a sexy job in the industry right now. Any data scientists in the room, or people dealing with analytics, advanced analytics? Yeah, well, a couple. Not so much, actually. But anyway, skills is pretty hard. And data scientists, they come from different forms. They may come from the mathematical world. They're pretty good at building algorithms and so on. They may come from the computing side. And they may lack a little bit the mathematical aspect of things. So it's good to have a tool that helps you to learn from your experience, to learn from the other, to learn from the community. Okay, and your journey in becoming a data scientist, whether you want to become a data scientist, is always going to go through skilling. So the learning curve is kind of steep, and the tool helps you in that sense. Okay, and lastly is the tools. So Clémence talked about IBM Cloud and the infrastructure. The last thing we want to do is to spend a lot of time and a lot of effort in deploying the right tools to do what we want to do. The data scientist and all the data scientists I've visited and I've interviewed, they all have their own set of tools. They have their own tools for data wrangling, data preparation, and they have their own tools to build models, to build predictive models. Then they deploy it in another tool. So that's a whole set of tools that you need to manage. And that's really tedious, and it's time consuming. So we don't want this, okay? And that's where the tools come in. So the tool is Watson Studio. So I'll try to go pretty fast. I talked about the skills and the peoples and so on. AI requires what we call a teamwork. AI is no magic at all. It needs a whole lot of investment. It needs a team, an entire team. And the tool is here for collaboration, mostly for collaboration, because you'll see different roles in the next slides, but we want to have a common set of tools, a common user experience throughout the different roles. And the roles and the personas are these ones. So if we start from the left-hand side, we have Tanya. Tanya, she's probably a domain expert. She knows the business really well. She knows the business challenge. She knows how to solve them. Not how to solve them, but she knows that AI or some sort of intelligence, let's call it that way, may help her to solve a business problem, may help transform the user experience from the customer standpoint. But she doesn't know how to do it. But she knows she's got a data scientist, Mike, in the company that knows how to do these things. Okay, so she might ask Mike to do this. And Mike has a good knowledge and a good understanding of deep learning, of machine learning models and so on. But Mike needs a data engineer. He needs Ed to get the data, to get access to the data, wherever it is, whether it's in your databases, internally, if we need to have a secure gateway, for instance, to access and to consume that data, if it sits elsewhere on the web or on a third-party provider, or if it sits on an Hadoop cluster, for instance. Okay, so maybe Mike doesn't know all of these things, but Ed is here to help him to do this, and maybe to help him in doing data preparation. You see the word ETL there, which stands for extract, transform, and loading. At some point, you might need to work a little bit around the data to get it well formatted and prepared for your data analysis. And lastly, we have Deb. Deb she's the developer, so she's the one who might use the tooling and the development tools that Clémence showed you, all the runtime, the Node.js, for instance, runtime, or the Liberty for Java runtime, anything like this, depending on all the mobile, for instance. And she's responsible of integrating AI artifacts into the front-end application, into the application itself. Being a mobile application, being a website, who knows, who cares? But she doesn't know anything about machine learning. She doesn't know anything about, not AI, but she doesn't know anything about how to do these models. But she knows how to consume those, because they're going to be consumed by an API. So all she needs is that Mike gives her the API so that she can access and so that she can integrate the machine learning into the application. And that comes to this AI workflow, which you can call an AI workflow, you can call it an analytical pipeline, you can call it a data pipeline, call it whatever you want. But basically, it always comes from first getting access to the data, connect to the data where the data resides. Then you need to find and understand your data. All business problem solving starts with understanding the data, understanding your business problems, and try to find out which data is going to help me to solve my problem. Then once you find your relevant data, and you prepare your data, you want to prepare your data, and there's a tool which is called the data refinery that helps you to do this, which helps you to do some basic transformation, things that you would do normally in an ETL. It doesn't replace an ETL tool, let's be clear on that, but it helps for business users, for instance, to do rapid transformation. Then let's assume that the data is prepared. Well, you can consume it and start building your machine learning models. Okay, and there's different tools for this. Remember, I said data scientists may come from different horizons, may have different skills. I tend to always classify those folks as the coders on one side, so the one that gets their hand dirty writing code, and the clickers on the other side. Those that have maybe less coding experience, but are pretty knowledgeable on using tools with their mouse, with kind of flow-based programming things. And guess what? The Watson Studio has also a choice of tools for these different peoples. Okay, from the coding part, and also from the I would say graphical design experience side. And that will lead you to basically train a model, train models, several models, evaluate the performance of your models, and once you're satisfied with one of your model, the next logical step is to deploy it. So to deploy it on a runtime so that you can use it to get a decision. Let's take an example. In the bank, for instance, you might have a model which is going to give you a credit score if you want to apply for a loan, whether you're a good candidate for the loan or not. Okay, pretty simple example. Well, once this is deployed, you want to pass new data coming in and get that scoring right. Okay, in the telco example, for instance, a telco company might get all your usage data from your phone. How you use, how many international calls do you do, how many drop calls do you have, and so on. And they may analyze this for churn prediction. Churning is when you are not satisfied with a provider and you quit to move to another one. Okay, that's not what they want because they're losing a customer. So they may have a model which will predict them the likelihood of a customer to churn. Okay. And once the model is deployed, it can be integrated, but that's not the end of the story because the models tend to kind of degrade. The models are trained on historical data, but you never know what the incoming data is going to be like. And you always have to monitor the performance of your model once it's deployed and once it's in a production environment. The reason for that is that most likely the performance are going to degrade and you might need to retrain your model or to loop back to basically to here, to retrain another model, build another one, deploy it, monitor, and on and on and on. Okay? So that's basically the story around the data pipeline. Talking about tools, Clémence talked a lot about open standards and open source. Well, we are fully committed to open source. So we rely heavily on open source frameworks and we integrate those in our tools. So I don't know if it rings a bell to you guys, but in terms of machine learning runtimes, we've got obviously Apache Spark, we've got scikit-learn, which is a popular machine learning library, we've got Spark MLlib as well, XGBoost, and we've got TensorFlow, Caffe, Keras, a bunch of things like this. So we're named PyTorch, for instance. So if you're interested in this, have a look at those. So these are mostly going to be used by the coders. And there's something else which we have, which is going to be used mostly by the clickers. It's this thing, the SPSS modeler. This is a flow-based programming approach in building predictive models, and I'm going to show you this in the demo. For the coders, of course, we've got IDEs, Jupyter notebooks. So think of Jupyter notebooks like TextPad, where you're going to write your code, but you're also going to write your logic, your mindset when you're doing your model training So you're going to explain where the data comes from. Then you have the code to extract the data, for instance. Then you say, well, you're going to analyze the data and you're going to find out it's not what you want. Well, you might write some code to tweak a little bit the data. Okay? So, rapidly over the tools, I'll skip this. Some user interface, which I'm not going to show you. I'm going to swap to the demo. It's going to be better. Okay, so let me share my desktop. There you go. So this is IBM Watson Studio. So it's cloud-based, obviously. So all you need is a browser, and you need to log in. So most likely when you log in, and you can try it, by the way, for free, you're probably going to pop up with this kind of message here, which is basically shortcuts to get the task going. So first thing you need to do is to create a project. And then once you create a project, you're going to find the data, refine the data. And basically, it's all the data pipeline I showed you earlier. Okay? Talking about some of the tools here in the toolbar, so you can see all the projects that, well, the recent projects that you've been working on. Some of the tools, and I'll come to this. The catalog, I haven't talked about the catalog. Let's make it clear right now, rapidly. The catalog is a way to share all the assets that you may have, all the data assets that you may have. So it's a nice way to search for data, to collaborate with your peers, but it's a nice way also to publish your models onto a catalog so that other people can use it. Okay, think of it as a big repository. There's one thing which the catalog allows you to do is this thing, Policy Manager. It allows to enforce security policies on sensitive data. Let's say you're in the healthcare industry, you've got patient data, the patient name, and all the things, sensitive information related to personal information need to be hidden. So you can build those rules, and you can apply those rules to the data assets. And the data is going to be anonymized, but still you can use it to build your models. Okay? So that was it on the catalog. So first thing, I'm going to, one other thing you might be interested in, talking about skills, there's a community which you can access to, which, okay, cool. It's a cloud-based tool, so from time to time. Anyway, there's a whole lot of articles, tutorials that you can access, and you can use those to train your skills. I hope it's going to work. So here I've got a project which I created. It's called Studio Workshop. And when I get in a project, I've got a whole lot of assets which I can navigate to. My data assets obviously are my data. So here I've got a bunch of files, zip files and so on. I also have connections, which are not shown, so I'll show you. I have connections somewhere, which allows me to connect to, let's say, 30, 40 databases or data repository. Okay, whether they're relational, NoSQL database, and so on. So here I've got two connections. One here, one here. Other things I can do in my project, I can navigate and have a bunch of models. So here I can have several models. I can have machine learning models. I'm going to talk about these visual recognition models, natural language classifier models. All the Watson services that Clémence talked briefly about need a tool at some point to be customized. Well, Watson Studio is the tool for this, so that's why you're seeing all these categories here. Notebooks, stream dashboards, and so on. Okay, so let's rapidly look at some of the data. One thing, no, I don't have time for this. So cars, let's look at a file. I've got a cars.csv file, which is shown here. Okay. So I've been told that I can go over schedule, so that's good. So I'm going to speak slowly now. So one thing that the tool can do is profile your. You can refine your data, for instance. So let's click on the refine your data, because you might find out that the data is not shaped the way you want. So you can you can do all sorts of operations there. You can remove duplicates, for instance. You can remove records or columns, variables that have null values in there. There's always a challenge when you have data which has missing data. As a data scientist, which is not the case in this specific data set, but when you're a data scientist, there may be important variables that you might want to use, but you have missing holes. So what do you do with this? That's a decision point where maybe you're going to derive those data, taking the mean of the variable for the entire data set, or you're going to just reject the data that has missing data. So in order to understand how your data is, there's a profile thing which shows you all the variables with the frequency and a bunch of statistics. So it gives you the min, maximum length, the mean of that specific column, which is the miles per gallon, so how much a car consumes, actually how much miles you can do with a gallon, which is like 3.8 liters of gasoline. So it's a nice way to look at your data, the profile thing. See how your data is balanced, see if you have any missing value, see if you have outliers as well. Another way to look at this is to use visualization tools. So you can visualize your data. It's a bit slow. And here, for instance, I can build a whole lot of charts. So let's build a chart with the let's say the horsepower and the miles per gallon. And obviously, let's get rid of this so that you see it a little bit. Obviously, you see a trend that the more horsepower I have in cars, the less or the higher the consumption is. So it seems to go down, but the thing is miles per gallon. Okay, so that's why with a small car that has not a big engine, we can basically drive more. We can see the trend if we want a kind of a linear regression there. We can have this thing linear. We can change a little bit. So let's look at the color there and see what I have. I've got origin. So let's color the data with the origin of the cars. And no surprise, we realize that American cars tend to consume more than the Japanese ones. And note that these things are interactive as well. I can change the size, for instance, as well. Let's look at the numbers of cylinders. And I can see, once again, that cars in the US, kind of muscle cars, they tend to like V8 and these kind of things. And if you look above 6 cylinders, there's no European nor Japanese car. One thing I forgot to tell you is that this is data coming from the 70s, 80s. Okay, it's not recent cars models. Okay, so you can use data visualization rapidly to understand your data and how your data is balanced, and that will help you in transforming your data. So back to the data there, I can do all sorts of things. I can remove duplicates, for instance. I can change this. So cylinder is not a string. Obviously, it's an integer. I cannot scroll there. Let's put it decimal in that sense. I can do all sorts of operations. So I've got mathematical operations that I can do on a column, and I can do whatever I want on these things. Okay, so I'm not going to go over this, but basically, when we're doing these transformation, what happens behind the cover is that we're building these steps there. So here we have what we call a data flow, which is a sequence of transformation options that I can run afterwards on a larger data set. Here I'm only working on a sample of my data, and obviously if my data is coming from a big data or from an Hadoop cluster, for instance, it's most likely that my data is pretty huge. So I can do my transformation on a preview or on a subset of the data, and then I can run it on a larger data set. If I don't want to use that kind of a clicker thing, I can also write code in here. And this is basically R code. So I don't know if anyone of you is familiar with R script, but if you are, well, you can write your code in there. There's always helpers that help you to do this, okay, which I'm not going to do there. So when I'm finished with tweaking my data, basically in the end I've created what we call a data flow. A data flow can be scheduled and it can also be submitted on new incoming data. I'm working on the cars.csv data. Let's say I've got a cars2.csv file, which has basically the same structure, but new data. I can apply the same data flow on that data. So now that I have my data prepared and working, things that I can do, I can build a predictive model, for instance. So let's start building a model using the clickers approach. So, yeah, do you think I have time to run it now, or maybe I'll show it? So here I've built this afternoon what I call telco churn. So remember the use case where I want to predict customers that are most likely to churn from my service. Well, I created this kind of workflow where I'm taking data, incoming data, which I can preview if you want to. So let's look at the data. And the data is consumption data from a telco provider. So I'll have a whole lot of information about the customer, maybe not who the customer is, but I may have demographic information, whether the customer is married or single, does he have a car, maybe an estimated income, is he married, how many children he has, and also I may have a whole bunch of information related to, come on, show me the data. And I may have all sorts of information related to the its age and how he uses the phone. So long distance call, so that's what he does on average on long distance call. International call, not any. Local calls, much more. Drop calls, did he experience drop calls or not? His payment method, so this guy is paying on a credit card. He doesn't own a car, by the way. He's part of a budget billing plan, so maybe an entry plan. And that's his overall usage of phone overall. And one thing I had over there was the churn column. And the churn column is a Boolean, true, false. That's what I see here. This is historical data. I know that this guy, customer ID 1, churned. That means he quit from my service. And that's what I'm going to use to train my model. I'm going to try to predict this specific column. So back to the flow now. I can do all sorts of things. I can type my column. So let's look at this one. When I read the data, so my incoming data, I've got 17 fields, which are all shown here. So the same fields that you saw, the ID, the children, the long distance, and so on. I can apply a role to these ones. And I'm going to apply an input role for all of the fields except the ID, because the ID basically does not have any impact on my churn, whether I'm going to churn or not. It's just an ID. But maybe the way I consume and the way I use my phone is going to have an impact. And the thing I'm trying to predict is, where is it? Okay, cool. Oh, God. You should see the churn column somewhere here. There it is. And the churn column is applied a specific input, which is a target. This is the column that I'm trying to predict. So what does that mean? It means that the model that I'm going to build here is going to learn and train on all the values except the churn and the record ID. And it's going to produce a model. Actually, it's going to produce a series of models, and which I'll be able to look afterwards. And it's going to compute also a whole lot of information about the accuracy of the models. So talking about the models, let's look at all the models I have here. I've got tons and tons and tons of models. So I've got a classifier. What I'm trying to do right now is a classifier. I'm trying to predict the churn value, whether it's true or false. So that's a binary classifier. Okay? If I would try to predict or cluster or classify customers in different groups, let's say I have my bronze customer, I've got my silver customer, I've got my gold customer, that will be a multi-class classifier. Okay? But if I'm not really good in machine learning and I don't know all of these models, I don't know what a Bayes network is, for instance, I don't know what a shade is, I could use this thing, which is an auto classifier. This is a node that will automatically select the best algorithms and the best machine learning models suitable for this specific use case. Okay, and that's what I did exactly here. And if I look at the response here, if I look at the model, actually I'm going to see that my auto classifier has chosen to evaluate 3 models: the random trees, the C5, and the NLP neural network. Okay, and here I've got an accuracy for all of these. Okay, so I've got a 98.5 accuracy rate for the random trees, which seems to be the best one, pretty close by the C5. So I'm going to look at this one in detail. So I've got a bunch of metrics there, which helps me to basically understand the model and the accuracy of the model. Accuracy rate is kind of a high-level metric, but it's not sufficient to tell you that the model is good. A nice way of looking at this is the confusion matrix. I don't know if the confusion matrix rings a bell to you guys, but this is basically the numbers of times that my model classified a customer as being a churn customer. So this guy has churn when in fact it did churn in the end. Okay, so that's what we call the true positive. And sometimes my model got it wrong. That means it predicted that the guy will not churn, but indeed he churned. Okay, so that's the false positive. And here we have the true negative, and here we have the false negative. That means this is the numbers of time when my model predicted that my customer will not churn, and it did not churn in the end. So how does that work? What happens behind the cover is that my data is being partitioned. The model takes like 80% of the data to train and saves 20% for testing, because it's historical data. So because it's historical data, I've got my model which trains on the 80% of the data and produce a model. Then using that model, I'm going to test the 20% remaining data to find out if I got it right or not, if the model was right. And that's what you saw, the confusion matrix. That's exactly the result of this. And that's how we compute the accuracy of the model. Also, if I look at the model information, I can see a whole lot of information in there. I can see the predictor importance. This is good. This tells me which variables are the most impactful in a churn decision. So obviously, in that specific model, it tells me that people with high income or low income, or at least with an income, drives the decision to churn or not. Then it's the age. Maybe I can say that elderly people do not churn that much, but young folks, guys and girls, tend to churn pretty rapidly. Long distance calls might be also a factor for churning, because that might cost a lot, like international calls. So maybe as a telco provider, I don't have the right plans for international calls. So there may be something to be done at that point. Okay, so that's a nice way to understand a business decision and why people are actually churning. Okay, so that was the user interface for the clickers. So now let's look, if I'm more into the machine learning model and I'm more into the data science, and I know what I want to do, I can build a notebook. Remember the Jupyter notebook? So that's what I'm going to do here. Actually, I'm not going to do it. I'm going to open it because I've done it earlier. So what happens here is that a notebook is related to a runtime. Of course, there's a runtime engine. So what happens there is my kernel, which is basically a Spark engine, gets started. Okay. It takes some time. It's a small kernel, only one virtual CPU and 4 gig. That's the free one. If you need something more, well, you can scale up, and it's not going to be free. It's a pay-as-you-go kind of model. So here, that's basically a notebook. So a notebook is pretty much a kind of a text pad. I can write in whatever I want, but I can also write code. So here I've got code, and here this code basically installs a library onto my environment, so I can tweak my environment. And here what happens is I'm installing wget just to retrieve the data and so on. And you notice the cells changes, so I can write the code there and I can run the cell. It's linked to a runtime. So here I've got a Python 3.5 runtime, and when the cell is run, I've got the results shown in here. So I'm not going to run everything because I've run it before for you in the afternoon, and I've got the results which are shown in here. So here I'm loading the data. I'm loading them into a Spark session. So Spark, that means it will run in memory. It's more powerful. Honestly, to tell you the truth, for the data I have here, which is like 2,000 lines, I don't need a Spark. It's just overwhelming to do it, and it's going to slow things indeed. But it will work exactly the same if I had like tens, hundreds of millions of records. Here, remember I said I'm gonna partition my data. Well, this is what I'll be doing here later on. Here I'm trying to basically use the machine learning from PySpark, so that's a library, so I'm importing the library, and from that library I'm importing the specific classifier, the random forest classifier. Okay, and here I'm starting to basically customize and tell my classifier on which specific indexer and which specific columns he needs to work on. Okay, and when I got this right, I'm passing it over to my classifier. So here's my classifier with all the features that I want to work with. Okay, and here I'm splitting my data. So I'm creating a train set and a testing set, and I'm doing a random split of my data, 80-20%. Okay, so I'm taking in random fashion 80% of my data and putting it in a train set, and 20% in the testing set. I'm putting this in the Spark cache, and then I'm training my model. This is what it's going there. I'm fitting my model on the train set. Once this is done, it doesn't produce any result, but it's just instantiate a model variable, which is a train model. So now what I want to do, I want to test my model. So that's what I'm doing here. And I've got my model, which is run with the test data, and I've got the probability and the accuracy rate here. So here, that's the actual churn rate, and that's the predicted value. So my model predicted right for this specific record. It predicted right for this one as well. It predicted right for all of those, actually. Okay. And then I can do a whole lot of things, evaluation, and calculate the ROC curve, which is a sort of accuracy variable, which comes with within the library, and it gives me a 90% accuracy rate. Okay. So this is basically what a data scientist will write. Okay. Another experience in terms of machine learning, and in terms of writing notebooks, for instance, I can use this one, and I can use it to visualize data. I used the data refinery things to visualize my data. But here I've got another set of data, which is exactly the same, the cars data, and I can use visualization library. So here I'm using a Brunel visualization engine, which allows me basically to look at exactly the same thing. So if you remember the the visualization I showed you, this is exactly the same one. And the Brunel allows us to build that visualization in just writing a single line of code. Okay, pretty powerful thing. Okay, and I can do a whole lot of things with this. Okay, I can build a chord, for instance. And talking about Brunel, if you guys are interested in Brunel, it's a library that you can use outside a notebook, outside Python. Okay, you can include it into your application if you want to. And let's finish here. What I did after training a model, basically, I wanna deploy it, and I can do it from here. For instance, my model. Let's go back into this one. My train model here can be. Let's move this here so that you can see. Can be. Oops, it's here. Sorry. Can be saved as a branch, as a model. If I do this, if I save it as a model, I'll have it shown in here in the deployed model. And actually, it's this one here. It's this one, sorry. The SPSS model, which I can deploy onto my runtime. Okay? And if I deploy it on my runtime, that's the trick. It's down for the afternoon, so I'm sorry I cannot show you this. But once it's deployed on my runtime, basically I can use it, and I can get code snippet to pass it over to my developer to use it. One last thing I want to show you is this thing. Before coming in, I trained a visual recognition model. Clémence talked about visual recognition. I'm going to rapidly show you how this works. I've loaded a set of zip files which contains images for a specific use case. My use case, let's say I'm in insurance, a car insurance, and I want to put in the hands of my users a mobile application which, when they have a car accident, they take a picture of the car accident, and it helps to file a claim to the insurance, and it helps to evaluate, for instance, the damage and how much it may cost to the insurance and these kind of things. So I've built what we call classes, and I cannot scroll there. I've built different classes, an accident class which has images, 245 images of car accident. I've built a broken mirror which shows a broken mirror, broken windshield, and a flat tire, and negative things. Negative class is a way to help the model to train and recognize things that are actually not of these classes. So these classes are considered positive classes. So this is a positive accident, this is a positive broken mirror, and this is a negative. So it doesn't have any broken mirror, it doesn't have any accident, and so on. And when the model trains, it's always a balance between the positive classes and the negative classes. And a positive class is considered negative for the other positive class. A broken mirror is not an accident. It might be part of an accident, but the way it works, it's not in that sense. Okay, so once I've built those classes, I can train my model. I did it, so I'm not going to do it again because it takes some time. But what I can do, immediately after this, I can test it. And I'm going to test it passing over this image, for instance. So I just drag and drop the image. And I don't know, maybe it's going to work, maybe not. I don't know what. The service has not been really friendly with us in the afternoon. I don't know why.
Try VPN.
Yeah, maybe it's due to the network. I don't know. Quoi? Yeah, I think there's it took me the afternoon to upload the images for some reason. Let's give it a last try. But in the meantime, remember when I talked about AI being, and I'll finish on this, AI being kind of a black box, but there's always a choice to build custom models and so on. That's exactly it. Slow. I think it's due to the network being a bit slow. It takes time to upload the image, it crashes the browser. Okay. Okay, so forget it. I don't know why the network's not working efficiently. But I hope you got basically the idea. And we have assembled a bunch of resources which you can access. So of course the Developer Works website, which is basically a website that has a whole lot of tutorials, recipes, and so on. And not only if you're in machine learning, and if you're in the cloud, if you're in the IoT, it's basically the developer's portal to IBM. So if you're a developer, if you're developing on IBM technology, that's your #1 resources. This one, the Medium, that's basically the blogging, or the labs write articles, a lot of articles onto this. So that's a nice way to get, not a chat with the labs, but the idea of the guys that actually develop the product, the development labs, and get a sense of what's coming in and what's new. IBM.com/Watson, of course, for all the Watson services. This is the console of your of the IBM Cloud. It was called Bluemix before that. Okay, so if you see Bluemix anywhere, Bluemix, IBM Cloud, same thing. Different terms, but exactly the same thing. And Bluemix is going to fall at some point. Dataplatform.ibm.com. That's the Watson Studio. So if you want to subscribe to Watson Studio, you go to that URL. And if you want to train, there's a website which is called cognitiveclass.ai. It's pretty good for training. It's got a whole lot of free resources, online videos, and it gives you badges as well, IBM badges, so kind of a certifications that you can pass. It's free of charge, of course. And if you do those courses, it's got individual courses and journeys. So roadmaps to become a data scientist, for instance, roadmap to become a Python developer, all these kind of things. And if you do those journeys, you can gain dollar worthwhile of computing hours in dollars on IBM Cloud. So you can extend your free services using like $1,500 of kind of fake cash, but of services on the IBM Cloud. So you can move from a free plan to a paid plan using this. Okay, and I'll stop it here unless you have any questions.
We will send the slides as well because some people asked me, so we'll send it to the organizer, and I guess they will share it with you. And also remember that we have a workshop on Saturday, and we will experiment exactly what we showed today. So IBM Cloud, we will build a web application using a database, a NoSQL database, and then we will build our own model with Watson Studio, and we will integrate these models calls in our web application, and so you will see the full cycle of the development of the AI application with our tooling.
So you'll get your hands dirty, and you'll have a chance to experiment this in a real hands-on experience. Okay, you've got our mail address there. So if you have any questions, feel free. We're not IBM support though, but if you need information or on navigating on the IBM's offering and these kind of things, feel free to reach us. We'll do our best to answer you guys. Okay?
Any question?
Yes, I have a question. First, thank you for the great presentation. And I have a question about mobile platforms. Can the Watson platform help us to prepare the model for uploading to mobile device? Visual visual recognition model for mobile device, for example, Android device.
You got it almost right until you said Android. So, well, talking about visual recognition, well, you realize that it's a service which is online because at some point it failed. What you want to do when you're doing mobile development, you probably want to have it offline. So the models that you train on visual recognition can be exported offline in Core ML, Core ML being the Apple's machine learning framework, so that you can package it into an application, let's say an augmented reality application that will recognize things through your iPhone cameras and will tag them in real time. So this is possible with Core ML, so that's on iOS devices only, and we don't yet have it on Android. But you can build using TensorFlow, for instance, you can build a model and export it, deploy it, and then use a TensorFlow Lite, for instance, to publish it onto your iOS, your Android device. Sorry, but out of the box right now with the tooling and with the ease of development, we only have Core ML. But I'm pretty sure other Android and Google's machine learning framework will come maybe in the roadmap pretty short. Okay? Does that answer your question? Yes? Okay.
Thank you.
You're welcome. Any other question?
And we have also a starter kit for working with Core ML and visual recognition that you can create for, but it's just for Apple, but you can start with the starter kit. It's already, I mean, you almost have nothing to do to create your app using visual reco and including your model that you deployed before.
Yeah, you can. Drop us a mail and I'll send you that recipe, and you've got the...
Yeah, there's a full tutorial.
Yeah. All you need to do is train your model, get the Core ML, boom. You've got a project, Xcode project, you've got a mobile application which is already built. All
And
you need
the
to
augmented reality as well,
Yeah.
capability integrated with this startup.
Okay? Yes.
First of all, thank you for great presentation. And pouvez-vous dire les exemples de collaboration entre deux clouds différents, par exemple le cloud de Google et le cloud de IBM.
Est-ce qu'on peut, tu peux répéter la question?
Je parle français.
Ouais, je sais. Non. Donc, alors, entre le cloud de Google et le cloud
et le cloud de IBM.
Donc, est-ce qu'on peut s'intégrer?
Oui.
Ouais.
Guys, just sorry, I can talk English as well. So I can talk French as well. When you talk English or French, we switch off other auditor. Yeah. So let's talk in Russian and translate. Because
I'll rephrase the question in English.
Okay.
Yeah. Okay.
In this
So.
case-
Sorry for
in
this.
case you have to answer in Russian.
Okay. That was my answer. I know nothing about Russian. This gentleman had a question about the integration of other clouds and so on. And in Clément's slide, the thing you saw on the right, the vertical bar, it was all about the integration, which allows basically to consume services from elsewhere, maybe data storage, for instance. If you've got your data on S3 hosted on Amazon, we've got a connector for this, so that's no big deal. API economy in that sense helps us to consume even maybe machine learning services from Google, from Amazon, from Azure. If you want to use the recognition service from Azure, you're free to do so as well. And actually, I've used it. I've used the three actually to compare those. I'm not I'm not going to do a competitive talk and describe which one works best or not. That's not the purpose. But yes, of course, you can integrate with other cloud services. You can build an hybrid cloud if you want to. What we don't want is we're not a vendor locking. Okay, you're free to choose. And when you saw all the runtimes that Clémence showed and so on, that's particularly to prevent vendor locking, so that you're free to choose whatever you want. You're free to choose your runtime, but you're also free to choose your cloud services where they run best and the ones that you're used to. Okay? Merci. Go ahead.
Thanks for the presentation. It's a bit technical question. You showed auto classifier, and are there some details on how it works? I mean, it is done for like research, or it use some sophisticated algorithms to select classifier?
Okay, so it depends. So that's the generic answer. What you saw in the flow modeler, it uses SPSS behind the cover. So SPSS comes with like 30 plus machine learning models already deployed. So it's kind of their own black box. Okay. Then if you're going onto Jupyter notebooks, you're free to choose any machine library that you want. So if you're familiar with scikit-learn, that's what you'll be using. Scikit-learn is going to be actually the model. So we don't do anything about models. We just integrate with the scikit-learn library. So we're not replacing this. Then if you wonder what's running, for instance, the visual recognition, which is seen as a black box, it's not coming from IBM research. It's using convolutional neural networks and so on. So it's built by the product brand using deep learning models, CNN in that case, and that's basically that's about it. Okay. One thing I forgot to mention, which is not in the slide, which might seem important if you guys are in machine learning, is all around the fairness of the models and the trustness of your models. Because as we're deploying artificial intelligence artifacts, we always want to know how the artificial intelligence actually came up to these results. Okay, and we're including in the platform a whole lot of tools to track this, to track how the model takes its decisions across the process. So we have a lot of bias detections kind of mechanism to try to find out if the model stays on track or not. Okay. So it's off topic. I did not mention it, but we would have to spend a day talking about this. Okay. Any other questions?
I hope it's last question. Hello, thank you for presentation. It was really interesting. So, and the first question is about the vendor lock-in. So, do you have any kind of Kubernetes as a service solutions? Like, so let's say we are building like a product that we want to sell, and we don't want to depend on IBM or Amazon or whatever. So we just want to push to our containers to the Kubernetes, and yeah. So the second question is about the tool, like Amazon Torque, Mechanical Torque. Do you have something like that?
Like Amazon what?
Mechanical Torque. You know, you have, let's say you have a lot of images, you want to tag these images, and a lot of people can do it for you.
Oh, okay.
Yeah. Thank you.
Yeah, okay. So first question, Kubernetes. Yes, we do. We have actually, it runs on Kubernetes. The Watson Studio that you see, everything like this, runs on containers deployed on Kubernetes. It's called IBM Cloud Container Services. And but basically what it is, behind the cover, it's Kubernetes cluster. And if you have already containerized your applications, if you have hundreds of Docker containers, for instance, you can always deploy them. So that's the service. So when you create the service there, what happens is it's gonna create a Kubernetes cluster. So you have a master node, and you have several worker nodes that you can deploy. When you're doing this, you can pick and choose the infrastructure that sits behind this, whether it's bare metal, whether you want VMs, for instance, these kind of things, it got an associated cost. You can test it because you can deploy a Kubernetes cluster for free. Okay.
Third-party services.
Sorry?
I can deploy to third-party services. Like I have my own infrastructure. I want to deploy to my Kubernetes.
To your Kubernetes? No, that's going to be more. No, that's going to be more.
Or I can export like images and then just build it.
You mean you build your Docker image and then you export them to?
Yeah.
Yeah, but that means you're the one running the Kubernetes service, right? Yeah, well, you can do this, but then there's no need of the IBM Cloud, or there's no need of IBM Cloud or IBM Cloud Private if you want to keep it in-house. That's the beauty of the thing. It's that it's managed, so you don't have to. You still have to manage your cluster, but you don't have to do the installations and so on. That's basically it. It comes also with a registry. So as you were talking about Docker images, it's got a container registry, which is basically the same thing as the docker.hub, dockerhub.com, but internally, which allows to maintain and manage your Docker containers. Okay. Second question. What was the second question?
About Mechanical Turk, like taking images, crowdsourced platform.
Oh yeah, crowdsourcing, validation of image. We are having it in beta right now. It's not going to be deployed yet. It's closed beta, so that means I don't have access to this. But if you're interested in this, actually the offering manager is a good friend of mine, so I can get some information about this. But it's going to come soon. It's like the fairness and the trustness of the machine learning models. Everything comes prepackaged. A part of the answer is it's called AI OpenScale. It's already it's already available. It was launched on September the 18th, so you see it's like a couple of weeks. And AI OpenScale is a service which helps to monitor the AI artifacts that you deploy, but also helps to integrate them into your application, and it builds some logic around this. Let me give you just, and I'll finish on this, a quick use case. You have, you're a rental car company, and you have, you're a customer, you rented a car from my service, and you were not satisfied, because when you picked up the car was dirty, it got a kind of a smell, and you're probably going to put this information into a feedback form at some point. Well, this information can be consumed by some of the natural language processing services of IBM Watson to find out that your feedback, say, well, the car had a bad smell, is pretty negative. And because it's negative, we want to do something out of this. And you can chain the reaction. So because it's negative, we want to do something. So what's the next best action to do to a customer which is not happy? Okay, and that may be another machine learning model. That may be another predictive model. Get started. À droite. Scroll à droite. Non, non, non. Ouais, ça, encore. You have something which is called AI OpenScale, which à gauche alors. Bah ouais, bah c'était là. Well, it should be there. Non, mais il est plus, putain. Foutu bêta. No, well, it's no longer there. I don't know why. So, up AI OpenScale. See, so that's basically the service which allows you to manage and deploy and manage in production AI artifacts. Okay? So it provides you visibility with what's within the AI artifacts. It's got trust and transparency in it. Scroll un peu en bas. It's got bias detection, mitigation. It monitors your AI while they are in production. Let's go encore sur les screenshots. And here, this is basically what you see. The screenshots there showed you basically several models there, and you've got these tiles, and you can navigate into this. Ouais, vas-y, la prochaine. And you can see the models and the transparency of the model and the trustness of the model as they were trained, as new data is coming in and so on. So you can see where they are biased. So here, this is a fraud detection model. So I highly encourage you to have a look at this. No? No? Yeah, what Clémence is saying, it's not beta. No, it's not beta. It got GA on September the 18th, but the private, the closed beta is for the crowdsourcing thing, which is going to come pretty soon. Okay?
Yeah, thank you.
You're welcome. So, well, we'd like to thank you again for the time, considering we're kind of over schedule already. And if you want to learn more, and if you want to get your hands on the IBM Cloud once again, Saturday, we're running a session, and it's hands-on lab, so it's going to be much less talk, and actually it's going to be you guys working, okay? And we're going to assist you. Okay? Thank you.
Deputies, let's thank.